Jai Hind all of you. I am Mahima Saxena, Assistant Professor at AKGC in Computer Science Engineering Department. Today, my first lecture is on compiler design. You all know basically what is compiler. Compiler is a tool in which we write a code and it will we run the code and it will give us the error, like what is the syntax error, what is the semantic error. Compiler is that compiler. The today's topic for this lecture is like what is basically compiler, what are the phases of compiler, what is bootstrapping in compiler, what is YAC compiler, why ACC is a compiler, is a very unique compiler which we are using or which we are used. So there are many things which I will discuss in this lecture. Now the first one is basically what is compiler. A compiler is a computer program that changes our source code written in a high level language into a low level machine language. Basically it translates the code written in one programming language to some other programming language without modifying the definition of the code, right? This is the basically compiler. So now this is the diagram, and in this diagram I'll explain what are the phases our code go through. The first one is I have the source code. The source code is then given to our front end basically, and then after semantic representation and then backend and then object code, and this complete process is called compilation. We will use compiler and these are the basically phases of our compiler. Like a overview of compiler in detail, I'll explain what are the phases of compiler. Now in compiler first I'll explain the phases of compiler first. We'll write this. First of all, what are the phases of compiler? These are the 6 phases of compiler. The first one is lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generation, code optimizer, target code generation, and after that assembly code. First we have high level language, and the second one is assembly code. Now what is a high level language? Our code is written in high level language, and the output which I'm getting with the help of these phases is in assembly language. So the conversion is required. Basically compiler does the conversion. Now if I'm talking about lexical analysis, what do you mean by lexical analysis? Lexical analysis is an analysis in which basically I have given some code. The lexical analysis phase convert that code, scan the code. In the scanning is done and generate the code in the form of tokens, and that token, the output of the lexical analysis phase is that token, and the input of syntax analyzer phase is that particular tokens. Hope I'm getting you understand this. Now the next one is semantic analysis. What is semantic analysis? Semantic analysis is basically first of all a syntax analysis. Syntax analysis is basically check the syntax of our code. Like after we generate the tokens, then we are checking that what the syntax of the question is suitable or not. Like this, we need to check the syntax. If any error occurs, that will be a syntax error generated by the compiler. The next one is semantic analyzer. Semantic analyzer is like here in this scenario or in this compilation, we use semantic analyzer as it work as a, like, we need to check the semantic actions like type checking. These are the type checking, like if there is any error, then it will generate a type checking error. The next one is intermediate code generation. In intermediate code generation, we have semantic analyzer generated the type checking and etc., and the intermediate code generate the intermediate code. If intermediate code is basically a code which is not in high level language or not in assembly language, it is the state of, it is in between high level language and in assembly language. The next one is code optimizer. If I want to remove, like if we have some lines which we don't required, then code optimizer will remove them, but the functionality of the program will not change, but the meaning of the program will not change. This is called code optimizer. The next one is target generation code. The actual targeted code is generated. and we have symbol table and error handling. Now, what is symbol table? In the first phase, I've told you that some tokens are generated, like that tokens, if token is already registered in symbol, if token is a value, is an identifier which is stored, basically it's a symbol table is a kind of a data entry dictionary something, or a table in which all the data is stored, and the symbol table is built in the first 2 or 3 phases, like in lexical analyzer, syntax analyzer and semantic analyzer. In these phases, the symbol table is completely built, and the last 3 phases, like intermediate code generator, code optimizer, target code generation, the last 3 phases will generate the code. Use that symbol table in future references. Error handling. Of course, if there is an error occur, if an error occurs, then the error is also be handled. The error handling will take care of that phase. The 3 phases, the 3 phases, lexical analyzer, syntax analyzer, semantic analyzer, will work as an analysis phase. And the last 3 phases, intermediate code generator, code optimizer, target code generation, are in the synthesis phase. Now, what is analysis phase? These are the 2 important phases of compiler. Now, what do you mean by analysis phase? In analysis phase, the source program breaks into constituent pieces and imposes grammatical structures on them. If deduct any error, user can take corrective actions, and all the information related to code are stored in symbol table, which are then be used in next phase. This is already I have told you. Now, what is synthesis phase? In synthesis phase, the target program is generated with the help of information in symbol table and intermediate code. This is the phases. Now, what is in detail? I'll explain it later. Now, but first, now I'll explain what are the passes of compiler. Now, we have 2 types of passes. The one is single pass and the other one is multi-pass. If I am talking about single pass compiler is used to traverse the program only once. The one pass compiler passes only once through the parts of each compilation unit. It translates each part into its final machine code. For example, according to the diagram, source code is given to compiler and the target code is generated. This is called single pass. But if I am talking about multi-pass, then it will, in multi-pass compiler is used to process the source code of several types. For example, the first here I have given the source code into front end, then in the middle end, then in the back end, and then in the machine end. And this is the phase where all the errors are generated. Possibility of generating error. This is called single pass and multi-pass. This is a very important topic for 2 marks question. So yeah, next is 2 parts of compiler, like analysis and synthesis. The analysis part breaks up the source program into constituent pieces and creates an intermediate representation of the source program, and also called as front end of compiler. Now, the analysis part divide the following phases, like lexical analysis, syntax analysis, semantic analysis, and intermediate code generator. These are the part of analysis phase. Now, if I am talking about synthesis, the synthesis part construct the desired program from the intermediate representation and symbol table, and also called as a backend of compiler. The synthesis part consists of the following phases, like code optimization and code generator. The starting phase, like the analysis phase or the 3 phases of compiler, also called as front end, and the last 3 phases of compiler also called as backend. Now, if I am talking about like legit definition of compiler, then this is the legit definition of compiler. A compiler is a computer program that changes source code written in high-level language into low-level machine language. It translates the code written in one programming language to some other language without modifying the definition of the code. Basically, in input, we have given the pure high-level language, and output, it will be an assembly language. Why we need a compiler? Why we want a compiler? हमें ज़रूरत ही क्या पड़ी थी compiler की? We need we need a compiler because the machine can't understand the human language and human can't understand the machine language. That's why we need to we required a compiler which is used for conversion into a high level language to a low language. That's why we need a compiler. Now, what is assembler? Assembler is a program that takes an input as assembly language program and changes it into its similar machine language code. Assembler is a program that takes an input as assembly language program and changes it into similar machine language code. Now, what is input assembly language? It is an intermediate state that is a sequence of machine instructions and some other beneficial records need for implementation. It is neither in the form of zeros and ones. Now, what is the output relocatable machine code? It means that you can load that machine code at any point in the computer and it can run. The address inside the code will be so that it will maintain the code movement. This is called output relocatable machine code. Now, what is linker and loader? A linker or link edit is a program that takes a collection of objects created by assemblers or compilers and combines them into an executable program. This is called a linker. Now, if I am talking about a loader keeps the link program into the main memory. This is the role of loader. The linker and loader used as a team. They worked as a team. Now, the most important thing is, what is the difference between compiler and interpreter? A compiler translates the entire source code into a single run, whereas an interpreter translates the entire source code line by line. It consumes less time, that is, it is faster than interpreter. An interpreter, it consumes much more time than the compiler. That is, it is slower than the compiler. CPU utilization is more. But in interpreter, CPU utilization is less as compared to the compiler. The next one is the compiler is larger. But in interpreter, interpreters are often smaller than compilers. The next one is both syntactic and semantic errors can be checked simultaneously, but in interpreter only syntactic errors are checked. The presence of an error can cause the whole program to be reorganized, but in presence of an error in interpreter causes only the part of the program to be reorganized. We need not to change the whole program, we only change the that particular part. The compiler is used by the language such as C, C++. The interpreter is used by languages such as Java. The next one is, I'll explain what are the phases of compiler, like lexical phase, syntax phase, semantic phase, intermediate code generation, code optimization, target code generation, and etc. I'll explain in detail in here. Now, first of all, what is lexical analysis? The first one is the input is given to lexical analysis is a source code, and the output is generated by the lexical analysis is the identifiers, tokens, keywords, literals, operators, etc. in the form of tokens. Lexical analyzer basically scan from starting to bottom, and it will remove the white space and comments between the code. It breaks the code into a meaningful sequence called tokens and remove white space and comments. This is the work of lexical analyzer. If I am talking about syntax analysis is basically the input of syntax analysis is token and the output is parse tree or syntax tree. Basically, the token generated by the lexical analysis phase is the input of syntax analysis phase, and the tokens are generated, the tokens are again refined and it generates a syntax tree or a parse tree, and we are trying to deduct the checks. Basically, we are trying to deduct the sequence, follow the grammar, or trying to deduct the syntax error, right? This is called the phase, this whole process is done in the phase of syntax analysis. The next one is semantic analysis. Semantic analysis is the tree is generated in syntax analysis phase. The output of syntax analysis phase is the input of semantic analysis phase, and the output of semantic analysis is an annotated syntax tree is the output. What is the idea of behind this? Basically, it verifies the semantic consistency. For example, type checking, undeclared variable, like etc. builds a symbol. Now, what is intermediate code generation? The input for intermediate code generation is a syntax tree that is generated by semantic analysis, and the output is the 3-address code. The 3-address code which is generated by intermediate code generation. Basically, the idea behind that is it converts high-level language to a form easier to optimize and translate into machine code. The next one is code optimization. What do you mean by now code optimization? The intermediate code, basically the 3-address code generated by intermediate code generation, is the input for code optimization. Now the output is optimize intermediate code. Basically, it helps to optimize the code. It improves code efficiency, reduces time and space usage without any altering program behavior. This is called code optimization. The last one is code generalization. Basically, the optimized intermediate code is used as an input in code generation. The output is target machine code. It basically, the role behind this or the idea behind this is it converts the intermediate representation into machine or assembly code for the target platform. This is the idea behind it. Now, I will explain what is code linking and assembly. Basically, the input for code linking and assembly is a machine code, and the output is that executable code we want. The idea behind this is resolves the references between code module and links library assembly object code into a final executable code. Moving to next topic, what do you mean by symbol table management? I have referred the diagram, like we have the symbol table and error handler. So now I'll explain what is symbol table and how do we manage a symbol table and why we need to manage a symbol table. First of all, a symbol table is a data structure used by a language translator such as a compiler or an interpreter, where each identifier or symbols, constants, procedures and functions in a program source code is associated with information relating to its declaration or appearance in the source. It is the various phases of the compiler as follows, like the lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization and target code generation. Now, if I'm talking about lexical analysis, like I said previously, create a new table entries in the table. For example, like entries about tokens. But in syntax analysis, add information regarding attribute types, scope, etc. Semantic analysis, used to verify the expressions and assignments are semantically correct, like type checking and update it accordingly. The next one is intermediate code generation, helps in adding temporary variable information. The next one is code optimization, uses information present in the symbol table for machine dependency optimization. The next one is target code generation, generates code by using address information or identifiers present in the table. The next one is error handler. As the name suggests, it is basically for handling errors. The task of error handling process are to deduct each error, report it to the user, and then make some recovery strategies or algorithms and implement them to handle error. What do you mean by errors? Like, I'll explain what are the errors, like lexical errors, syntactical errors or semantical errors. If I'm talking about lexical error, it includes misspelling of identifiers, keywords or operators. If I'm talking about syntactical errors, missing semicolon, unbalanced, parenthesis, etc. Semantical errors, incompatible value assignment or type mismatch between operators and operands. These are the errors, these are the possibilities of error that a program can generate. Now next one is, if I'll explain what is lexical analyzer, like the detail of, if I am given an example, it is the first phase of compiler and it is also called as a scanner. As the name suggests, the scanner scans the source code character by character, delimits by some white space character, operators, punctuations, etc. and separate the token, identify the lexical units in the source code. It reads the stream of character of source code and group them into a meaningful sequence. For example, the token must be represented in this form, type and lexeme value. This is an example like D is equals to A plus B into C. As a programmer, we know that A, B and C are the identifiers and plus, equals to and multiply are the operators. So we represent this into a this type of a table called symbol table of this. Obviously, the first one is identifier, the second one is operator, identifier, operator, identifier, operator, identifier, operator, and these are the value. This is the representation of lexical analyzer. Kind of this, we represent this in a format. Just like that, all the other phases represent different things in a different format. This is the complete, it's a very important topic from university purpose. It's definitely come and it's definitely asked. If the interviewer asks about the what is compiler, he or she will definitely ask what are the phases of compiler, like which phase perform which type of functions and what is its quality. These are the things and you need to know about it. Thank you for today's lecture. I'll explain some new other topics in next lecture. Thank you very much.